Hello viewers, welcome to this course on practical machine learning using Google Colab. In this tutorial, I will be describing about an image descriptor, which is nothing but your color channel statistics. So an image descriptor means it will try to describe the image in terms of a number. So we try to represent an image in terms of a feature vector. So here we are going to use the color information and represent it as a vector. So let us go into an application and try to understand this color channel statistics algorithm. So here when I take a color image, basically it will have three channels: red channel, green channel and blue channel, and each channel will be represented by a matrix. So for the matrix, we can compute the statistical parameters like mean, standard deviation, skewness, kurtosis, etc. So in this application, I am going to use two important statistical parameters, which is your mean and standard deviation. So we try to take the color channels, find the mean value and the standard deviation value of the color channels. So this will represent the color distribution in an image. So once I get this color distribution in an image, then I can compare two images, whether it is having similar content or not. So that we can able to identify by using this color channel statistics. So if you look at this diagram, so in the top I have two images. If you take the mean and standard deviation of the left image and mean and standard deviation of the right image and make a comparison. So how to do the comparison? We can compute the Euclidean distance between the two feature vectors. So when I do the distance computation of these two images, feature vectors, then we will obtain a distance metric. So if the distance metric is small, then the two images are similar in nature. If the distance metric is large, then the two images are dissimilar in nature. For example, on the bottom I have two images. So here when I compute the feature vectors of both the image and find the Euclidean distance, we might get a higher value of distance metric, which indicates that these two images are not similar. So what is Euclidean distance metric? We will try to see it. So if I consider two vectors P, let us take some vector P, which is P0, P1, it goes on till Pn. Same way, let us take another vector Q, which has elements like Q0, Q1, it goes on till Qn. So let us assume these are the two feature vectors obtained from two images. So first image has given me this P vector, second image has given me this Q vector. So now I want to find the distance between these two vectors. So for that we can make use of the Euclidean distance metric. So where the Euclidean distance d of this P and Q vector is computed by root of P0 minus Q0 whole square plus P1 minus Q1 whole square. It goes on till Pn minus Qn whole square. So if I compute this value, I will get the distance between the two vectors. If the distance is small, is less, then the two images are similar. If the distance is large, then the two images are not similar. That is how this distance computation is carried out using a Euclidean distance metric. So what are all the steps involved in our color channel statistics? First step is separate the input image into respective channels. and then we compute the statistical parameters. So for this application we are going to use two statistical parameters, mean and standard deviation. Since I have three channels, I will get a mean value for red, mean value for green, mean value for blue. Same way standard deviation value of red, green and blue will be obtained. So altogether I will get a 6 elements in a feature vector. So once I form the feature vector, then we can make a comparison between the two feature vectors by computing the distance metric. So now let us dive into the program. So here what we are going to do is we are going to use a data set which has 4 images. I have these 4 images: lion underscore 01, lion underscore 02, lion underscore 03 and lion underscore 04. So what I'm going to do is I'm going to extract the mean and standard deviation value from these 4 images, and I'm going to make a comparison. Which images are similar in nature, which image is not similar in nature. If the distance value is small, then the 2 images are similar. If the distance value is large, then the 2 images are not similar. So that is what we are going to do in this application. So let us execute the program. So first we try to import the necessary functions. Like we have the Euclidean distance function available in your SciPy package. From SciPy package, I am going to import this distance metric. Then in order to visualize an image, I am going to use cv2 underscore imshow function. Then in order to get the path of the images, we use the third-party library imutils. From imutils, I am going to use the function called as path to extract the location of an image. Then numpy is a numerical Python library which is used for doing some matrix computations, and cv2 is a computer vision version 2 library which has lot of image processing algorithms. So after importing all the necessary packages, I am going to get the location of images. So I have stored my images in the Google Drive. So what we do is I try to take all those images path using this command path.list underscore image, then I try to sort it out. So all the path of the images, I have 4 images, 4 image path I try to get into this image path variable. Then I create an index dictionary. So right now it is empty. So what we do is we try to put the file name, index of file name. For that file name, what is the feature extracted. So like that we try to create this dictionary. Then print the image path. So when I run this, you can see, so this is the first image path, lion underscore 01.jpg. Then second image, lion underscore 02.jpg. Same way I have lion underscore 03.jpg and lion underscore 04.jpg. So we take all the 4 images. Now one by one from the image path, one by one path I am going to take using this for loop. From image path I have 4 paths. So from that one by one I am going to take as an image path, read that image, then I am going to extract the last location. So in order to do that, I am going to separate out this path using this image path.split function. So I am going to split each thing, content, drive, my drive. So like that I am going to split the path. So and I am going to take the last location. Okay, so the last location is lion underscore 01.jpg or lion underscore 02.jpg. So like that we are going to extract that information as a file name. So file name will have lion underscore 01.jpg, lion underscore 02.jpg. So like that lion underscore 03.jpg and lion underscore 04.jpg. So that we try to extract here. So I am trying to print the file name and see how it is. Then I am sending the image to a function called as cv2.mean standard deviation. So this function will compute the mean value of color channels and the standard deviation of color channels R, G and B. So I will get 2 lists, mean a separate list, standard deviation separate list as an output. So I want to make it as a common list. So for that, what we do is we do np.concatenate and make it as a flattened vector. So once I get the features, I try to print the features and see. Then what we do is we create a dictionary. So index of file name with the features. So index of file name means it will be something like lion_01.jpg. These are the features. Same way lion_02.jpg. These are the features. So like that it will get created. So let us try to create it. So you can see here. So this is the file name lion_01.jpg. So this is the feature vector of the first image. So as you see, you have 6 elements. 3 for mean. The first 3 is for mean. The next 3 is for your standard deviation. So mean value of red channel, green channel, blue channel. So in Python, it will be in an opposite format. So the first value will be the mean value of B, mean value of G, and mean value of red. Same way, standard deviation value of B, standard deviation value of G, and standard deviation value of red. Same way we extract these features. So this is called as a feature vector obtained using color channel statistics. So now we can make a comparison. So in order to make a comparison, I am going to take a query image. So the query image is the first image I am going to take, image path of 0, which is nothing but this lion_01.jpg is our 0th index image. So that I am going to take it as a query image. I am going to see that image. Then I try to sort the keys. So the keys are nothing but this lion_01, lion_02, 03, 04 are the keys. I am going to sort it in ascending order. So when you execute this, you can see the query image and also you can see the keys. So what is my query image? So this is my query image. Okay, image path of 0 is nothing but this lion_01.jpg. So you can see the keys here. Okay, keys are nothing but lion_01.jpg, 02, 03 and 04. So now what I am going to do, I am going to take these keys one by one and I am going to find the Euclidean distance between the keys. So since my query image is the first image, okay, the first image is my query image. So if I compare this first image with the first image, then I will get distance metric of 0, right? Because both the images are same. So I'm not going to do that. So what I do is, if my k value is lion_01, then I'm not going to compute the Euclidean distance metric. I'm going to come out of this for loop. If k value is not lion_01, if it is 02 or 03 or 04, then I am going to compute the distance metric. So that is what we do here. Okay, so if this value is not matching, in that case I read that image, then find the Euclidean distance using this function, distance.Euclidean distance. So what I am going to need to compare? I need to compare the index of lion_01.jpg with the other images. So the other images are given by this k. So after computing this, I will get a distance metric. So this distance metric, I am going to put it on my image. I am going to put it on my image, the distance metric at this location 10, 30, and with this font. So this is the size and this is the color. We are going to write it in green color with a font size of 2. So this is what we are going to do in our program. So when I execute this, you can see when it is compared with the second image, you can see the distance metric. Okay, so I'm going to compare the first image with the second, third and fourth image. So my first image is this one. So I'm going to compare this image with second one. Second one is this one. So when I compare this image with the second image, you can see the distance metric is 172.80. When the first image is compared with the third image, it is 78.32. When the first image is compared with the fourth image, it is 39.44. So which means from this distance metric what we can conclude, this two, first image and the fourth image, are similar in nature. First image and fourth image are similar in nature. So this is how a feature vector is obtained using color channel statistics algorithm, and it can be used to find whether the two images are similar in nature or not. So in this tutorial I talked about color channel statistics algorithm, right? So here in color channel statistics we extracted the mean value and standard deviation value of color channels and use an Euclidean distance metric to make a comparison. If the distance value obtained is less, then the two images are similar in nature. If it is not, then they are not similar. Thanks for watching. Please subscribe for more technical learning. So you can find the code of this program in this GitHub repository link. Thank you.